So the last little section of dynamical systems and forces is what happens to pulleys in elevators. So this is an even more strange situation because, again, you don't really see people using weighing scales in lifts, and even more rarely, or what is pretty much impossible to see, is a pulley inside of an elevator. So the tension in the string holding the particles together would increase. That's the first thing that would happen. Because particles naturally have inertia, so that's a resistance to motion and a resistance to change in that motion. So the tension will try to combat this urge for inertia per se. The particles will have a new acceleration, which is denoted as b, relative to a fixed point. However, we're just going to be talking about the accelerations as seen in the lift instead of by an observer. With an observer, this b acceleration is known as an absolute acceleration, which means it's relative to a fixed observer. However, we're going to imagine that we're in the lift with the pulleys and noticing the change in acceleration there. To an observer, they're both going to be incredibly shocked, and they will perceive an acceleration that is different to the actual acceleration because the lift itself is accelerating away from it. However, the people in the lift are accelerating with the lift because they're inside of it. So their acceleration inside of the lift is 0, but the lift is also causing an acceleration on the particles, which changes their dynamics drastically. It is a very confusing topic, I'll admit that. But the maths part of it isn't too difficult. If you just get a bit of signage change and a little bit more on simultaneous equations.